My name is Sander van der Raalte. I'm one of the product managers for Moldflow in Autodesk. I've met many of you over the years. This is a virtual event. This is the best we can do at the moment with the COVID crisis. But one of the positive side effects of organizing it this way, virtual versus a virtual in-person event, is that this gets to be a global event. So we get presenters from all over the world presenting on how they use the software and some of the things that they have invented, which I always find interesting because as a product manager, I get to see how different parts of the world use Moldflow in a different way. And this is an opportunity for you also to see what others are doing. So I hope you can take some of this back and as ideas in your own work life. So today I'm going to be talking about a number of things. Two things in particular. I'm going to be covering what's coming into the upcoming Moldflow release, as well as what we are working on, sort of in the longer term, with connecting Moldflow technology into the Fusion platform. So when this presentation airs, we should be well into our Moldflow 2021 beta program, and many of you should already be set up for providing feedback and testing the release. So I'll be making forward-looking statements that are not available in the current software yet, so please do not make any purchasing decisions based on the statements I make over here. We do intend to be as honest as we can in these presentations, but things may change and you can hold us to statements being made over here. So I'm going to cover two areas. Like I said, we're going to cover the upcoming Moldflow release as well as the sort of longer term vision of building Moldflow technology and connected it to the Fusion platform. But in the Moldflow update section, I'm going to be covering three areas. First, security. Secondly, productivity, and then lastly, the third area is going to be the accuracy area. There's been a significant amount of change in the last number of years, the way software is being used, not only in Autodesk, but basically how companies thinking about cloud computing and cloud computing in particular. One of the things we continue to hear about, like our intent to actually deliver cloud services, is but what about data security? And honestly speaking, that's an area that is clearly something we have to own and spend a lot of time on. Like if you trust your data to us to be hosted there, we have to make sure that you are comfortable with doing that. So as a company, we actually stood up a team of data security experts who are educating the internal development teams, as well as developing best practices on how you develop software for the new era, as well as like giving you insight how we as a company think about data security. So, and this is a very important piece of how we as a company now going to move forward. So this team has stood up basically in implementing changes into the way we as a product team develop software. So throughout the year, whenever we do a build of the software, it gets automatically scanned for security flaws and compliance issues or coding errors. And this being also being a 40-year-old code, we had a lot of codes to bring up to meet the standard. So last year, we spent a very, very large amount of time as the entire product team to go through the code line by line and bring it up to meet the standards that were set for us. So, and that's a good thing. One of the side effects you're going to see is that all these little coding flaws that we may have had, or like things that are like look innocent, but may have actually destabilized the software in certain areas. So you should see a more stable product as a result of this. This is a first step in this direction. Data security is not a one and done. The requirements for what we have to meet are going to be more and more stringent over time. Our requirements, and that's a good thing because, like I said, it should be part of the way we think about product development, not only as in feature functionality, but like data security and how third parties might exploit things. It should be part of the way we think about it. So your data should be as trusted behind our firewall as it is behind your firewall. And like I said, this is an evolving thing. The teams are setting new requirements and we will have to meet those going forward. So big investment. And we've already seen some of these things actually working out in the next slide. So if you would have had this conversation 10 months ago or 11 months ago, I would have said that the intent was to release Moldflow 2021 in the March-April timeframe with the current job manager. However, in the January timeframe, our security team came back and said, hey, you guys are using two components in the old job manager SJM that are not compliant, and you have to upgrade them to a higher version. And that actually would have triggered on our side a tremendous amount of work to actually get compliant. So instead of doing that work and abandoning it because we were committed to a new job manager already that was quite far down the line, we decided to instead actually fix that new job manager SCM that wasn't at the time when we made this call not far enough in the development pipeline to be commercialized by the normal release time. But it would have saved us a lot of time along the way. So we instead decided to commercialize that newer job manager SCM, simulation compute manager. And this is basically from the ground up development based on modern data transfer protocols that are widely available in other applications as well. So we expect this to not be as big of a burden on security scanners, for instance, that we've seen in the past here and there. So it's also like it's going to have a couple of really interesting things built into it in the sense that there is a strong queue-based workflow in there. So you can actually set up, let's say, your network in a way that one machine is going to be just the manager of a batch queue, and other computers can point to it and pull jobs from that. Similar to what you would expect from a HPC effectively. So there's going to be some interesting capabilities built into it. And one of the other things that you can actually send your colleagues that are also on the network a way to view the job manager. Or you could, let's say, submit your jobs to a queue, send yourself a link to the queue viewer, and you can just say go home, go back on PPN, and see how your jobs are progressing. So it's certainly like a very interesting new step, and then there's additional benefits we can build on top of once we have this out. So we didn't only do this sort of these security updates and sort of replacing existing functionality. We also looked at can we do things that are going to help everybody do their job better on a day-to-day basis. So every time we went to user meetings, almost every time we hear somebody ask like, hey, but what about, for instance, the sync marks in Moldflow in Moldflow. So we've known for a long time that if ribs get wider or get shallow, our ability to predict sync marks of the rib is limited. So we see in this particular case, the ability to actually predict sync marks on these ribs is somewhat limited. In the upcoming release, we do see our ability has drastically improved. So we see now all the opposing ribs having sinks, including the areas that are, let's say, you could hardly call as a rib. It's more like a thickness increase. So I would say this is going to be a massive improvement for everybody on a day-to-day. Another thing we added is the ability to change legends options. So we've always had these red to blue rainbow plots, but in some cases, like some people are colorblind, they have a hard time seeing certain colors. We have now certain legends that you can set that's maybe more appropriate for you, what the colors you can see. Another way to look at it is like it is sometimes difficult to compare experimental results to our Moldflow results. So in case, let's say, birefringence, the way these things are displayed is dramatically different from what we actually show in Moldflow. At least they're hard to correlate. So with these new legend options, we give you ways to do more apples-to-apples comparison and make the comparison between experimental data and things you might see in reality, like in simulation, easier. Another thing we added is an automatic packing profile. This is, again, the intent behind it is basically to at some point replace the default packing profile, which is at the moment 10 seconds for 80% of the maximum injection pressure, with a packing profile that's appropriate for the particular part. So the end result is going to be that you get a better, let's say, warp prediction out of the gate, or more plausible than what you would have gotten with sort of the standard default packing profile, or that you actually might have to rerun the packing because, let's say, you after the analysis completed, you determined that the part didn't pack out completely, so we needed to extend the packing profile, and therefore you have to rerun the whole analysis again. So this hopefully should get you a better warp results from the beginning without actually having to rerun the analysis. Also made some good improvements in the weld surface predictions and the area, like we've seen in some cases where the weld surfaces that are important for, let's say, linking Moldflow results to Helios PFA for structural purposes. Those weld lines were sometimes disconnected or spotty. The new algorithm should actually give a more continuous and appearance, so less spotty and less disconnected. That should help the structural analysis as well. And then we have various valve gate improvements in the software as well. I'm not going to go into the details there. We also implemented some new technology, polyurethane foaming. And actually, we call it chemical foaming in the upcoming release. So, but it's basically polyurethane foaming aimed at companies that make freezers or that make things that use a great amount of foam, let's say, for thermal insulation or acoustic insulation. So also for automotive interiors, sometimes like you see textures on inside the dashboard of a car. The leathery textures are sometimes actually polyurethane foamed on top of plastic. So this should be a good improvement for those particular areas. This is not all we've done. We've done a lot more than just these particular areas, but this is all I can cover for the time I have today. The second part of my presentation is going to be about transitioning some of the Moldflow technology into a Fusion-based platform. And the intent is not to just do a port or like a one-to-one translation of what we have today onto the Fusion platform. We're going to have a chance to take a step back and say, okay, based on the technology we have, or let's say that what Fusion has to offer, are there things we can do differently and more appropriately for the user personas in play? Are there things we can use the information that's inside the Fusion platform or the design to help us make decisions in a better way than what we've done so far? Currently, in the Moldflow world, we're very much used to taking data apart and bring it into Moldflow, run the analysis on it, but we have no idea what that part is and what the context of the part is. Fusion actually allows us to say like, hey, the part is designed in Fusion or it comes in as an assembly into Fusion. Are there things we can do to that to make better decisions? One of the key things to understand is like that Fusion 360 is a cloud-based product development and manufacturing platform connecting design to make. So the intent is to capture data that's not only like residing on the design side, but also connecting it to the manufacturing technology and everything in the middle. And this is actually an opportunity for us as well. If you think about it, like when Synergy was invented 20 years ago, the fastest computer we can get was a 2 CPU single core machine. The world has changed clearly, and the compute platforms have changed, and you can now deal with multi-core machines with multiple CPUs in there. So, and that's sort of by default nowadays. However, Synergy is still actually running on a single core. We did a lot of upgrades over the years, but it is still inherently developed in a different era, a compute era. So Fusion is developed on today's technologies and on today's platform, and actually provides us an opportunity to make a massive step forward in the way we provide content to user personas. So when I mentioned connecting design to make, the way we think about it is like there are different people involved in the development of a plastic products, and those go from design all the way to somebody actually making something roll off an injection molding machine. And there are different people involved that are all taken the pieces of the information, hopefully, and can contribute to it. And if they're not, there's a good chance that there are disconnects. The disconnects cause problems. How many times have you, as a Moldflow analyst, seen cases where like the warp predictions didn't match, and then you start looking into it, and it turns out that the molder actually has a different process, or the analysis that you run was on design version 4, where the part actually being produced may have been like altered in significant ways that are no longer actually matching what you actually were running in the back. And there was just simply no time to connect, let's say, the Moldflow simulation again into the latest design changes. So if everybody works with the same data and is informed when changes are made and can consume those changes in a very easy way, that would be a huge benefit in terms of avoiding errors and avoiding disconnects. The other thing is, like, all those personas can actually be part of different companies, and Fusion intends to become a platform where, like, the owner of the data can be sort of the design firm, but everybody else can get access to certain areas of the design for them to consume and contribute to. And when updates are being made, they can ripple up and down the chain and inform people that are who the changes are relevant. So for our first implementation of some of the Moldflow technology in Fusion, we're actually going to target the May persona, which is the Moldflow simulation analyst, and Kabir, the engineer. And I want to say the first target is going to be primarily Kabir. So think about Kabir at the moment like has a lot of the DNA of sort of the Moldflow advisor users, but this is primarily just get a first step on this platform. So the intent for the workflow is going to be enable collaboration between the different users, as well as making sure everybody operates off the same model. It's a single part analysis. We give them sort of a simple way to set up the analysis, as well as an easy way to interpret data. I think particularly if Kabir can provide more information about requirements and upfront, you should be able to actually provide really targeted results and see where they are within tolerance or within meeting expectations and where they're not meeting expectations. Data is going to be created in the cloud. It's also going to be made in the cloud, and the data will reside there permanently. You can export it to your traditional Moldflow products to complete work, let's say, particularly because of at first the Fusion workflow will be very limited, but over time we expect, and you should be able to complete the work on your traditional Moldflow product, but over time we actually hope to make sure that the cloud-based experience is going to be as good, if not superior, to the existing desktop products. So we're going to try to answer three very basic questions for what can be in the first phase. So the first one is basically, will my part fill? And this is effectively the good old confidence of fill prediction, and try to give the customer an indication of where the problems are. The design is going to have problems with filling, and give really targeted solutions on how to resolve those. The second one is basically going to be around the visual defects. So will I have visual defects, let's say sink marks and weld lines, in areas that are going to be of importance to me from a visual perspective? And if so, what can I do to resolve those? Also intending to have some way to visualize the results in a way that you can, let's say, transfer the data or make the data visible to the designer, and so that the designer can understand, okay, if I have a high gloss surface finish, I'm going to see this sink mark, but if I apply a texture or make the surface more dull or change the color, I will be able to hide the defect properly and see if that's an acceptable trade-off. And lastly, will our part warp too much? So this is going to be first phase over like that we're going to implement, but the intent is basically to look at what are the requirements in terms of tolerancing and how much out of plane warpage can I accept for, let's say, my part to be part of the assembly. This is where I think over time the fact that we actually understand the product context, not only the parts but also like how it fits in an assembly, is going to be very beneficial, because we should be able to derive information from that as well. So the intent is basically to give the end user a really targeted information to the area that we are looking at. You should also be able to like still go back and interpret data you have done in over time, like not only in the guided way to look at results, but also get all your results that you've had in the advisor product so far. So you give a way to, if you want to use the guided workflow, as one way. If you want to use sort of the more traditional way we've had simulation of an advisor done in the years, there's another way to use the software as well. But like I said, this is a first step, and we will need to build this out further and complete the work over time. Another workflow we intend to bring to market is like the workflow for May. Again, this is going to be a superset of what Kabir has, plus some additional options to for May to be more precise in not only setting up the analysis but also like interpret the analysis. This is going to be, again, like she has all the tools available that Kabir has, plus all the bells and whistles that you've come to use in sort of the Moldflow Insight product, with some limitations at first. But like I said, for instance, it will be a single part only analysis first. But if you want to to continue your work inside like your traditional product, you can export the model to your Insight product and actually complete the work and build your tool around it and say multi-cavity and see what happens with sort of the more traditional tools. So we intend to keep the results in sync and allow you to actually export a fusion model with data on it into a way that can be opened up in Insight, ideally speaking, with results. So the takeaway from this is basically that you've known Moldflow for a very, very long time and as sort of the leader in our market, and we're not going to go anywhere. This is like we're going to continue to enhance and improve our product, while at the same time we're building out the workflows within a fusion context as well, because we do believe that actually there's a tremendous amount of value in actually understanding the context of a design and being able to put data into the model, not only like a CAD model, but when I say model, it could be like flatness or predictive information. It could become part of this model, so as a component. And there's a tremendous amount of benefit actually to allow other people than just you to benefit from sort of these things. And so also like the world has changed quite a bit, right? So even though we still hear like a lot of resistance against things in the cloud, and we do at the same time see a lot of companies nowadays actually using things like Microsoft Teams, employing data, like collaborative data. And this is actually Fusion is a very similar way to think about it, as a collaborative platform for engineers to get things connected from design to make. So with that, thank you very much for your attention, and I hope to see you in the next in-person user meeting, and thank you for your attention.